Great. All right. It's an odd experience just talking to a screen rather than a room full of people, but let's hope that it works. So there's the title of the slide, and you can see the play on words implicit in this, the ethics of AI or the AI of ethics. And I'm trying to make this a bit of a provocation, right? So I'm trying to make it interesting. Let's see how we go. All right, so let's dive straight into it. Let's think about the ethical problems of AI, artificial intelligence. These arise when AI methods are applied to data about people primarily. So that can include all manner of things, whether it's bank loans, sentencing decisions, placements of advertisements, media content selection, essentially whenever there's an action affecting a person influenced by an AI system. And many of these have now been copiously documented. So there's a big literature on the AI of ethics. But I want to try and think about this in a deliberately different kind of way. And one of the questions I want to ask is, if harm is being done, what is to be done? What should we do? Right? And there's certainly different views on this around the community. Now, one common response that you'll see a lot of press on is bias. Right? Bias, it's a four-letter word, comes with a lot of baggage. You can talk about biased estimators, right? Statisticians have been doing that for a long time. Biased algorithms, biased data, and biased decisions. Now, one thing all of those notions have in common is that it's a problem with the technology itself that we need to go and fix. And I claim that this can lead us to some faulty conclusions. I'm going to present a caricature of the ethics of AI. It's slightly unfair, but I've got the floor, and that's what a caricature is after all. So I think a caricature of the ethics of AI might run as follows. Machines have bias, and thus they should not, quote, make decisions about people. We're going to come back to that, make decisions. Furthermore, AI is fundamentally different to other technologies, so the lessons of the past aren't much help. Ethics is essentially principles, and if we figure them out, we can fix AI. Furthermore, ethical reasoning is all done inside a human's head. Ethical decisional autonomy is binary and unambiguous. I unpack that phrase later on. Decisions that you might make with a machine are conceptually, spatially, and temporally atomic. They're discrete things. You've either not made the decision or you've made the decision. Furthermore, more information always helps in decision making. And finally, kind of as a conclusion of sorts, ethical decision-making should be reserved to unaided humans, not machines. Now, there's lots of approaches to this, right? And I'm not going to try and survey them all. This is a nice picture in the sense that it's overwhelming. I'm not expecting you to read that. I don't even know what the resolution of the video link is. This is from Harvard. It's an attempt at a categorization of a large number of published AI ethics principles. There's been a whole bandwagon on this. Lots of organizations and countries have gone and done this. Now, to be slightly unfair, I think this is a bit like saying that, you know, if you want to make your existing technology, whether it's a motor car or a power station, all of those adjectives on the left, reliable, repairable, efficient, environmentally responsible, you can add to this list. They all sound nice, right? Who doesn't want all of them? Of course you want all of them. But wanting them, and even just writing them down, doesn't solve anything. So what are we going to do? The pictures are just little interludes, section breaks, and they're to remind you that I'm talking all the way from Australia. This is based on a photograph from the middle of Australia. So what are you going to do about the ethics of AI? So there's this precept that I'm very fond of due to the mathematician Jacobi, right? It's a way, when you're faced with a problem, it's a meta principle about what you should do in order to solve the problem. And Jacobi says, always invert, right? If you're attacking the problem from a forward direction, look at it from a backwards direction. Now here, I'm just playing with words in this and saying, instead of the ethics of AI, let's think about the AI of ethics. What does that mean? What does that phrase lead us to? And as I said, to reiterate, it's to provoke and inspire. Now, thinking about AI, we can use the word technology. It's a big word. There's two shorter words in English that I think are appropriate here, and that is tool versus machine. And I think the distinction between them matters a bit here. Sherwood Washburn, so there's a number of interesting quotes, interesting to me anyway, in my talk. He was an anthropologist, and he made this rather bold statement: in a very real sense, tools created Homo sapiens. That's clearly not a new idea. But here's the thing I want you to think about. What's the difference between a tool and a machine? Now, nowadays, most of us would probably have an electric drill in our toolkit. It's a tool that we can use to drill holes in walls. We take it for granted. 50 or 100 years ago, that would be considered a quite fantastic machine. The little stone axe on the left, that's clearly a tool. So perhaps this distinction between tool and machine is simply a matter of familiarity. And perhaps AI, rather than being a machine, and particularly a scary machine, it's a tool, and once we become familiar with it, we can use it as a tool. We still have to be careful, like the saw in the picture, that we don't cut our hand off, right? I actually cut myself with a rather sharp knife recently. Tools are dangerous, so we need to take care. Another very common theme that you'll see in the literature of the ethics of AI is transparency and explainability. The whole field is very big on these big abstract nouns, right? I mean, you can write a lot of papers about them. But I want to ask the question, rather than transparency and explainability of an AI system, why don't we turn that to ourselves? Let's ask the question, transparency and explainability of our own minds. Another way of putting that is, do we know our own minds? And we tend to think that we do, but when you go and study it systematically, we don't. Right? Jonathan Haidt says, we will have very firm views as to what is right, but we'll be utterly unable to explain why. That's in the context of moral decision making. Charles Peirce said, writing 100 years ago, was talking even more generally about how few things are more completely hidden from my observation than those hypothetical elements of thought which the psychologist finds reason to pronounce immediate. You don't really know your own mind. You don't know why you're thinking the things that you're thinking. So it's an interesting conundrum, right? We demand transparency of AI tools, but we don't demand it of ourselves. Trying to understand the reason why we can't do this is because the way our brains work is terribly complicated, right? Molly Crockett, a scientist at Yale, studies human decision-making. We tend to think that, there's just a single us, a single me. I make the decision. I've either not made it or I've made it. Bam, it's done. Actually, there's all of these systems operating in your brain, and you don't really understand how this works, right? Joshua Green, a psychologist at Harvard, says the same, essentially the same thing. And one of the interesting points that he makes, the last sentence I quote there, is that he's talking in particular about our moral thinking. When we're making moral decisions, he makes the point that it's fundamentally actuarial. All right, actuarial as in actuaries, as is in insurance, as in one of the starting points for statistics and data processing. Should we? Another take I want to think about is, should we actually more fundamentally worry about our machines doing our thinking for us? Surely, one might say, in the case of really important decisions like ethical decisions about who gets bail or not, right? I mean, this is a big thing. We don't want to go and delegate that to a machine. Surely we should keep it to ourselves. Now, the counter view is actually quite old, right? So both Alfred Whitehead and William James said this within a year of each other. I think it was like 1905. And Whitehead's quote, very famous, I want to read out. Civilization, sorry, the background is that, he's saying that people say that if only everyone thought more, if you only thought more carefully about all of the problems of the world would be a better place. And his counter to that is this: civilization advances by extending the number of important operations which we can perform without thinking about them. All right? William James says essentially the same thing, right? The more details we can hand over to the effortless custody of automatism. Very big words there, but he's delegating it to a machine. The more our higher power of mind will be set free for their own proper work. Now, that was 100 years ago. It's still a controversial point, I think. Nevertheless, even kids get it. So Sherry Turkle from MIT, in one of her books, had this phrase that jumped out at me. She's quoting a young girl in grade 6, talking about what it's like to program a computer. What's, when you're programming a computer, what's the interaction between the person and the computer? So Deborah's view is that when you program a computer, there's a little piece of your mind, and now it's a little piece of the computer's mind. You've taken something, we don't quite know what it is, out of your mind, and you've put it into the computer, for the computer to do your thinking for you. Benjamin Franklin said a similar sort of thing with his prudential algebra. And this changes the way you frame the question. And there's a nice symmetry. You can see I'm a fan of this symmetric trick with words. There's this nice symmetry then between, rather than talking about artificial intelligence, talking about intelligence augmentation. We're going to come back to that later on. And the distinction is that you're not just saying you're going to automate everything. We're not just saying we just give it to the machine and then we never go and think about it. It's like all of our machines, right? The knife that I was using to cut the bread that I cut my hand on, right? Without that knife, I would have had a heck of a time slicing the bread into nice pieces. The knife helped me do it, but I was still in control, or mostly in control. So the idea is you don't aim to replace the human, but you try to augment them. Another concern when you start to think about artificial intelligence is that it gets tangled up with this notion of consciousness. And consciousness is a very hard problem. And the reason it's a hard problem is it's rather hard to define what the problem really is. There's this nice idea by this lady, Catherine Hale, started out as a chemist, but she ended up as a professor of literature. And she has this nice phrase of non-conscious cognition. So don't reserve the grand idea of thinking to entities that are conscious, like we are, right? So my favorite example is just a thermostat. A thermostat doesn't do a lot of thinking, but it does do a bit, right? It pays attention to its environment, and it changes its behavior according to certain simple rules. And so one of the founding fathers, arguably, as significant as Norbert Wiener, W. Ross Ashby, in his book on cybernetics, I think it was 1958, he actually talked about this phrase, intelligence amplification. That was his motivation. His motivation was not, we're going to go and build machines that can think on their own and then go off and do things. He was thinking of, how can you build machines that can help us think better? And I think that this is related to the distinction between the tool and the machine, right? A tool is a lot less confronting, right? It's something that it's in our hands, we're controlling it, it's not autonomous, right? So this notion of autonomy, I think is quite important. Now, so I started to think about, I started going down this line of thought, and I thought, well, are there some nice historical examples that we can lean upon? What can we, we're really sort of starting from scratch here. People, there are real pressing problems on how you can, bake appropriate ethical behavior into these machines that we let do some of our work for us. What can we learn from the past? So I was very excited to learn, after digging around for a lot. There's a very nice analogy. It seems nice to me. Now, we know analogies are dangerous. They're very, they can be very productive. They can give you new ideas, but it's not a proof, right? There's no proofs in this talk. It's a, we're at the pre-proof stage, I think, in this area. So this guy at the top is Havelock, Eric Havelock. He was a professor of classics at Yale University, and he wrote several books on the development of Greek thought. So this is going back a really long time, right? 2,500 years or so. And the thing that absolutely leapt out at me, right? So you've got to realize that I'm an engineer by training. So I'm reading this book about, ancient history, and it all sounds very interesting. And there's this sentence: the Greek alphabet is a piece of explosive technology, revolutionary in its effects on human culture in a way not precisely shared by any other invention. So just think about that. This guy, a professor of classics, all right, he describes this very subject matter of his research as a piece of technology. The Greek alphabet is a piece of technology. And Marshall McLuhan, I mean, these guys worked together, they interacted, said effectively the same thing in different words. Language does for intelligence what the wheel does for the feet and the body. What's the wheel? It's a tool or it's a machine, right? And what does it help you do? It improves your ability in locomotion. That helps you move faster. Well, the written word helps you think fast. It helps you think better. And so there's this phrase, the technologizing of the word, due to Walter Ong. Jack Goody, another anthropologist, called writing a technology of the intellect. Some folks argue that, so the usual story about writing is that writing is a communication technology. Well, of course it's a communication technology, right? I'm using it now to communicate with you. But there is some scientific work that argues that, well, first up, it was a cognitive technology to help you think. Then the communication function got co-opted. Walter Ong wrote this book about technologizing the word, and I won't read his, well, maybe, yeah. So the key point he's making here is that, it's like these technologies, once you've learned to ride a bike, you tend not to really notice it. It just helps you go faster, right? So likewise with writing, it's very hard for us growing up in such a literate culture to not see that we're actually using a tool that we kind of take for granted. And what does the tool do, right? It helps us think better, right? So, we're all smart, we're all researchers. Our ability to think is essentially the thing that earns us our daily bread, as it were. And my point here is that this old technology, it helps us think better. So let's think about that a little more. All right, let's think, in what respects does it help us? So Harold Innis, also working around the same time as the previous two folks, the way he put it was, it's kind of obvious, right? I mean, that writing helps you with memory. But it's not just making your memory better, it's changing the character of it. It's providing a transpersonal memory, right? It artificially extends your memory, and it kind of outsources it. And once you start doing that, you have to have symbols. And so he makes the point that individuals apply their mind to symbols rather than things. So you've got this notion of this abstraction, right? This very elementary notion that you can have a thing and you can have a representation of a thing. What better way to describe what data does, right? So, Innes made the point, I think this was in the 50s, that this is a quote from him, writing enormously enhanced a capacity for abstract thinking. And man's activities and powers were roughly extended in proportion to the increased use and perfection of written records. Eric Havelock used even more flowery language, not flowery, flamboyant language, I guess, to make his point. And he credits Plato with the best invention ever. It's an interesting thing. I've got several books on inventions, and people play this game of what's the best invention ever. And you could say language is one of them. Well, Havelock reckons that it was the invention of abstraction. That idea of abstracting away from all of those particulars and seeing some more general pattern, he calls it the greatest invention ever made. And he makes the point that first, like from a kind of general philosophical perspective, you can't actually have conceptual thinking without abstraction. There's this famous story by the Argentinian writer Jorge Luis Borges, Funes the Memorias, who could remember every detail. It was sort of like just, I don't know, drinking from the fire hose of the internet. You can't make any sense of it at all. The only way you can make sense is to have abstraction. And then Havelock goes further, right? He wrote this book on the Greek concept of justice. And this is what really got me interested in this, because there I was trying to think about how you build ethical AI. And there he is, like 40 years ago, making the point that you can't actually have the concept of justice without the ability to abstract, right? the very notion of justice is an abstraction. You can't talk about things being good or bad, right? Those notions are abstractions. And then he defines a philosopher is one who has mastered abstraction, a man who is prepared to challenge the hold over the concrete, over our consciousness, and to substitute the abstract. So what have you done? You've worked out a different way of viewing the world, right? Rather than just the raw data, you've kind of processed it in some way. You've built symbolic representations of it, right? They're abstractions. And how did you do it? You used technology to do it. Which technology did you use? The written word. Merlin Donald, another anthropologist, talks about the development of theoretic thought, right? So he distinguishes between early cultures that didn't really have any theory. There's also caught my mind. I'm a theoretician, so of course, here's this guy saying that, essentially the modern world got created once the theoreticians turned up, which I think is not unfair at all. And the way he described what was going on here was it was not only external memory, it's external symbolic storage. You need both. You want to sort of swap out this nebulous memory that's in your head, the face that you saw yesterday or the pathway to the beach. You need some symbolic representation of it because that's what gets recorded. It's not your memory per se, it's a representation of it. So you've got all of those representational issues. So my claim then is that, you can argue that human ethical decision-making has always relied upon technology. It's not a new thing that we've got to go and grapple with, that we've got to go and solve. It's the only way that we've actually been doing it forever. So I think that kind of changes the game a little bit. This is a nice quote from Daniel Dennett. I don't know if it's original to him, but it was in one of his books. Back to carpentry and edge tools. Just as you cannot do very much carpentry with your bare hands, there's not much thinking you can do with your bare brain. Now, I wanted to give you another example, which I found stimulating in this regard. So I've been talking about, when you think about technology and artificial intelligence, people immediately start thinking of very fancy electronic gadgets. But technologies come in all sorts of shapes and sizes. And the French philosopher Bruno Latour made this very nice observation that I like a lot about the ethical technology of speed bumps, right? So, when we're driving a car, we always want to go fast. Of course we do, right? When other people are driving cars, when our kids are around or we're a pedestrian, we want them to go slow. So this is a classic, societal kind of problem. So how do you solve that? Well, one way of solving it is to delegate the control of the speed of cars to a piece of technology. Which piece of technology? The speed bump, right? So it gives you a different perspective on a speed bump. A speed bump is a technological embodiment of an ethical principle. And if you didn't have speed bumps, you can have all sorts of signs up, but we all know that they don't work as well as a speed bump, because a speed bump, if you do go too fast over it, is going to cause you harm. Anyway, I thought that was a nice example. So just to sum up where I'm up to in the argument, so what's all this got to do with the ethics of AI? So point one, justice requires abstract thought. We use the technology of writing to help us make it clearer. So why not rely on the natural descendant of such symbol systems, such as writing? Why not ask a machine to help us make our ethical decisions, right? That's everything I've done so far. That's really just leading up to the kind of the point that's presumed in applying AI, right? That's what we're going to do. We're going to have these machines that are going to make consequential decisions, or maybe help us make consequential decisions. But that kind of begs the question of what do we mean by making a decision, which I've deliberately put in scare quotes there. And at first you think, well, surely that's obvious, Bob. You decide whether or not to have another piece of cake or not, right? I mean, what else is there to it? So one way of making the question more precise is to reframe it like this. Exactly when and where do we make decisions, right? So if we just say we make a decision, where in your head do you make it and when do you make it? So Dan Dennett, who knows an awful lot about neuroscience, says the following: when we look closely at a person's conscious decisions, we discover that this quest for spatiotemporal precision breaks down, creating the illusion of an isolated, powerless self. We restore power and hence the potential for moral responsibility to the self by recognizing that its duties are distributed in both space and time in the brain. So if you study what's going on when people make decisions, the science shows that there is no single point in the brain where the decision's made, and there's no single point in time where it's made. And it's even more perverse than that, right? Even if you suppose that there was a time, then the time you think you made the decision is not the time you actually made the decision, right? It all gets quite complicated. And even without that complication, there's a further complication I want to talk about, which is setting aside the processes going on in our head. Let's just try and understand what we mean by a decision. Now, to try and set this up mathematically, right? So for a statistical decision theorist, a decision is a map, it's a function from some set of inputs to an action space, right? We all know what a function is. Feed one thing in, get something else out. But no, you can have different types of decisions. So that's a function. And, you know, computer scientists work with all sorts of different kinds of functions, in particular higher order functions. What do higher order functions do? Higher order functions return a function as the output. So you can think of things like, I could make a decision whether to take an umbrella when I go out tomorrow. So I can do that in two ways. I can decide right now, yes, I'll take the umbrella. Or I can decide on a function, which I will evaluate tomorrow. And then when I've evaluated the function, then I'll know whether I take the umbrella. So tonight I decide I'll look out the window and see whether it's raining. Note the difference. Today I'm working at a more abstract level. Tomorrow I'm applying it. So you can think of it as going down one order of the function. What's different between those two decisions, right? I'm going to use the same word for them. I don't have a better word for it. So the thing I'm doing tonight or the thing I'm doing tomorrow, what's different in them is the different levels of discretion. Tonight, I'm using my full reasoning power, let's say, right? I am unfettered. I can make up any decision rule that I want. I could try ringing up the Queen and asking her if I should take my umbrella. I could do all manner of things, right? But tomorrow, right, I've kind of constrained myself, and the only thing I'm allowed to do is to look out the window. I could still ignore it. If it's pouring rain, I could still choose not to go, to take the umbrella. So what's different is the level of discretion, right? It's the degrees of freedom that I'm giving myself. And Elliot Jacques, a famous organizational psychologist, he made a big deal about this, about, you know, if you're trying to understand why some people can end up being the CEO of a huge corporation, whereas others get completely overwhelmed if they're given too much responsibility, it's to do with these levels of discretion. It's the levels of abstraction that you can work at. He actually wrote a book called Levels of Abstraction in Logic and Human Action. So think back to Havelock's portrayal of Plato as the guy who invented the biggest thing ever, namely abstraction. Well, there you see that same idea played out in modern organizational psychology in the 1960s. Anyway, so discretion and delegation go together. So I could, instead of the decision rule that I just described, a variant would be I ask someone else to look out the window for me. I tell my wife, here's the rule. I mean, she wouldn't do this, right? But suppose she would, right? I say, tomorrow, could you please look out the window for me? And if it's raining, hand me the umbrella. I get the same effect, right? I made the original higher order function. She, quote, merely executed it. Hopefully you see where I'm heading with this. Now, this idea of making one general decision now and then having perhaps some other thinking entity make the more fine-grained decision later on, I claim is actually at the core of many of the applications of AI, a core of many of the ethical problems to do with AI. This is David Mindell talking about autonomy, right? So I hadn't used the word yet, but you think about, you know, the discretion to make these decisions. Tonight, when I'm making that big decision, I'm entirely autonomous, right? I can kind of do whatever I want within my reasoning limits. Mindell says this, for the 21st century then, autonomy is human action removed in time. This, in a sense, is the essence of the term programming, telling the computer what to do at some point in the future when the program is run. So instead of getting my wife to look out the window, I could build a little computer program. I could have a rain sensor. It's a small amount of code, and it's making the decision. So then you see where I'm getting at, right? Who's making the decision in that case? It doesn't make sense to say it's me entirely. It certainly doesn't make sense to say that it's the machine entirely. It's some kind of symbiotic relationship between them. And that notion that decisional autonomy is graded, that you can have some aspects that have a very large amount of freedom and others that get narrowed down, we've actually met this before. This is the invention of bureaucracies. It's the invention of our legal system. So this guy is Charles Curtis. He was an American legal scholar in the 1950s. And, you know, here he's talking about what happens when you execute certain code. So you've all heard, you know, Lawrence Lessig, code is law, law is code. Well, here we are, we're talking about the law. The law is code in the same way that a computer program is code. And he's talking about how you interpret what written legal documents like contracts and statute law mean. And he says, you know, lawyers have been brought up in the belief that the interpretation of these documents consists essentially in a search for the intention of the author. So that approach is essentially saying there's just one level of abstraction, there's one level of decisional autonomy, right? And you just resolve that and it's done. But he goes on to say, the grave fault of the orthodox theory is that it assumes that the author retains control over his words after he has uttered them. Words in legal documents are simply delegations to others of authority to apply them particular things or occasions, and the more imprecise the words are, the greater is the delegation, simply because they can be applied or not to more particulars. So his whole point about the way you interpret all legal documents, he's making a very general point, is that it all comes down to that degree of discretion. So you can, I'm sure, think of examples about, you know, laws that are written in very general terms and they give a lot of latitude to a court to go and interpret. Or you might have other things that are super specific. Okay, so hopefully you see the analogy there between, you know, my toy example with the umbrella, whether I'm delegating it to my future self, whether I'm delegating it to another person, whether I'm delegating it to a computer. So another pause. We're good about 2/3 of the way through the talk. So I've tried to you know, talk about the problem in general and come at it from a number of different ways. At the moment, I'm still just, I think, heaping complications and subtleties on top of subtleties. But, you know, in the end, engineers want to solve problems. And so, you know, what are you going to do? Well, one of the greatest engineers of the 20th century is Claude Shannon. There's a fantastic movie about him, which I only got to see a couple of days ago. And, you know, founding father of information theory. And he was described, you know, his ability to solve problems was described as his ability to reduce the problem to its essence, right? So rather than saying, let's start with a whole stack of principles and, you know, it's super complicated, what's the minimal core of problems that you need to solve in order to deal with some of the ethical problems of AI? So I claim that, and I can justify this, and I'm not going to get you to go, I'm not going to get a lot of details through, but a lot of the problem comes down to throttling information flow. It's counterintuitive, right? So let's design mechanisms to do that well. So I'll justify it shortly, but let's just think about what this means. So you know, computers are information processing devices. My computer can store a terabyte of data. And so, you know, you think it's vastly more capable than my brain. And now I'm saying, no, actually what I wanted to do is to prevent information flowing. But they can do it better than us. I mean, we're terrible at this. A game I used to play with my daughter is to say, well, try not to think of an elephant. That's the one thing I want you to do, is to not think of an elephant. Well, of course, you can't not think of an elephant, right? Humanity's developed lots of mechanisms that are information throttling mechanisms. Sortition, just drawing lots, is a way of doing this, right? Because it's a randomized procedure that just prevents the wrong information from being used in making a decision. William Vickery, a political scientist, had a similar argument to do with how you can prevent gerrymandering, you know, drawing up boundaries of electoral districts. So you have to go and rule certain things out in advance, and there has to be kind of this barrier where information can't flow. And it turns out this is an old idea in philosophy. John Rawls, very famous moral philosopher, talked about this thing called the veil of ignorance in trying to set up a just society. But it's actually quite tricky. So one of the interesting insights the machine learning community's contributed is this notion that you can't just go and say, well, to be fair, we don't want to take account of a person's race or sex, so we'll just not use that information. But of course, they're correlated, right? So if you know the person's name, it's pretty easy to work out their sex. And machine learning algorithms will just go and do this, right? They're all about learning patterns. But once you start thinking that the problem here is controlling that information flow, not taking account of everything, but controlling how it gets used, then I think in principle, you can make better decisions with a machine. The reason why the problems of ethical AI are so interesting is that they are intrinsically stochastic. Most of the literature on ethics doesn't talk much about uncertainty. There's this paper, I mean, it was a pretty easy Google search to track this down by the New York philosopher Russell Hardin, where he talks about ethics and stochastic processes. And, you know, he has a lovely example about vaccination, you know, because there's the positive thing that the vaccine will immunize the vast majority of people, but for a small number of them, it'll cause great harm, but you don't know which is which. And so then the question is, how do you go and make your decision? If you think in terms of individuals, you can't resolve the problem. You have to think at a populational level. And you have to think, you have to take account of reasoning at the level of the individual, and the group and the society. These are things, I'm just using different language, these are things that underpin a lot of machine learning. Now, this idea, I'm going to skip that. I want to give you a cartoon idea to get a little more concrete about ethical machine learning, right? So I don't know how this animation will work over the internet, but here I'm plotting, I've got 10 people, I'm measuring the loss of a predictor. It might be whether they get into a college or whatever, and I'm running my optimization algorithm, and it changes, you know, it changes the weights in some representation. And then we go and converge on the hypothesis that has the smallest average loss. That's our goal, right? So vast majority of machine learning problems can be described that way. I want to make those numbers small on average, right? And so I get the average loss of the best hypothesis. This is vanilla machine learning. So now let's do the same thing again, right? But now I've got people of 3 different races, the red, green, and the blue race, right? Nothing else has changed. It was the same picture, but it's in color. So what are you going to do? Well, one thing we could do is we could say, well, why don't we group all of the blue people together, the reds together, the greens together. Note the indexes along the bottom. I've just permuted it. I do the same thing. Nothing has changed except I've permuted them. And again, I get the average loss of the best hypothesis. I'm showing the same graph over and over again. Now I can compute conditional expectations. I can compute the average loss of all of the blue people, the average loss of the red people, and the average loss of the green people, right? Shown hopefully on your screen now. And so now I can, I hide a bit of the information and I just say, well, let's look at the groups overall. And you can see just by looking at this here, that the blue people do better than the green. Remember, I'm plotting the loss, so smaller is better. So in this situation, the people in the green race have been somehow disadvantaged, you could say, right? There's some measure of fairness. So what are you going to do, right? I mean, you could minimize the average, you could minimize the maximum. There's lots of different choices that you could make. Now, it turns out, glossing over a lot of details, this problem has been considered in philosophy long ago. John Rawls would argue, and spent 500 pages in his book arguing, that what you should do in this case is to minimize the maximum loss, right? You put all of your attention on the worst off. John Hassani will argue, again, with very compelling arguments, that what you should do is the average loss. And there was this huge debate over decades about, which is better, because they're quite different. Now, my favorite technical trick to solve this kind of problem is when you say, well, you've got two things, you've got this thing, you've got this other thing, you ask what's in between. And then it reduces to a nice mathematical problem. Essentially, you're saying what's in between the maximum and the minimum. And it turns out, this is a good thing, this problem's already been solved, right? It's solved in mathematical finance and in economics. And I'm not going to explain the equations. The only purpose of putting them up there is to say there is some maths behind this, and the details are in the paper that I'll point you to. You actually get a family, and there's a very nice parametric family that allows me to interpolate from the expectation to the maximum. And I'm sure all of you could dream up a particular one, but this one's particularly nice. You'll just have to trust me on that. It's called the conditional value at risk. There's other variants. Nevertheless, it kind of feels arbitrary, right? I was making all those highfalutin statements before. It seemed like I was going to come up with some principled way of doing things. There is a fancier argument you can make. I'm not expecting you can absorb this at all. I just wanted to say there is an argument you can make where you can axiomatize things. I need to skip that because I'm just conscious of the time. So my point there is that you can start with this very simple problem. You turn it into a mathematical problem. There's no unique answer, right? We know that it's common in engineering and science, right? Engineering in particular. There's no best motor car, right? I mean, you might want a cheap car, you might want a safe car, you might want a fast car, you might want a sexy looking car. Each of those optimization problems will have a different answer. But, right, what you can do is you can delineate the entire family of solutions, and you can then, using the maths, using the computer, you can solve these problems in a more considered way than you could have done if you're just trying to use your own reasoning. That's my point, and that's the power of using the machine to do the ethical reasoning for you. So is it enough, right? So I'm heading towards the end of the talk. We have a few minutes to go. This idea that human history is essentially the history of better tools. That's an old idea that quotes from like 1890 or something or other. Thinking in terms of AI versus humans making decisions, one crucial point here in green, which I think is completely undervalued today, is that algorithms can be reprogrammed. They can also be audited. It's much harder to recode social systems and institutions than computers. Compare a bureaucracy with a piece of software. If I want to change the way the bureaucracy works, there's a whole discipline for this. It's called change management, right? If I want to change the way the algorithm works, I just push a new version out, right? So how might you go about doing this? Actually, I'll skip that. Suppose you do this. Suppose you're using machines to help you make these decisions. Is it really that simple, right? Am I really saying that all of these challenging ethical problems can simply be solved by a little bit of maths and some clever data processing? No, I am not saying that at all. But what this line of reasoning I think does make clear is where the really hard problem is, and it's not with the technology. There's a quote from this senator from Minnesota over 100 years ago. He's talking about, our masters have a corner in the hole out for the inventions, but they're now just as employed to the destruction of human rights as formerly, in the absence of those inventions, the people's ignorance was used as a means. Just because you've got a more powerful technology doesn't mean you're going to be nice, right? That's what it comes down to. So I want to give you an intriguing example that illustrates the information processing idea. And it shows you why it matters whose hands the tools are in, as perhaps to a greater degree than what those tools are. So Ronald Dworkin, the American philosopher, made this observation about a character in one of Tolstoy's novels about his moral principles, right? He was talking about ethical autonomy and where people get their moral ideas from. And he says, or Tolstoy says, Stefan's beliefs are not actually his because they are borrowed. They are borrowed without him even being aware of their source. And it is implied Stefan is not capable of giving some account of their validity. What am I talking about here? What I'm talking about, what Tolstoy was talking about, was that Stefan was reading the newspaper. Stefan had all of these ideas that he just absolutely believed in. This is the right thing to do. This is the way we should manage COVID. This is my idea. But no, he got that from reading the newspaper. So what's that got to do with the ethics of AI? Well, if you think about the way news is done nowadays, right? It's an information processing problem. Machine learning underpins it. You get served stories that the corporation that serves you those stories thinks will benefit the corporation, right? That's how news works. That's how advertising works. So you've got these different flows of information. Here's a stack of individuals. The corporation can learn a lot of information about the individuals. The normal concern about privacy is to limit those upward flows, control those blue arrows, prevent the corporation from learning specifics about you. But machine learning allows them to build highly predictive models of you without necessarily knowing the secret particulars of you. That's the power of the machine learning models. What's rarely spoken about is how you control the yellow arrow. The yellow arrow is the one that actually does the harm here, right? The corporation can manipulate you, get you to do what they want, get you to think what they want you to think, without actually knowing the details of you, without even knowing your name. So to understand these systems, you have to understand information flows. And this is largely neglected. Rikke Jorgensen made an empirical study of data scientists working with real data on people. And she was interested in human rights. And she observed that the data scientists, they just kind of took it for granted, right? You take data for granted. It actually comes from the Latin word meaning to be given. Dare means to give, right? You just think it's just given to you and you can go and do with what you want. So my point to finish up, I've got one more slide to go, is that I think much of the work on the ethics of ML is arguably solving the wrong problem. So it's certainly true that there's interesting technical work to be done on making better machines to help us think better, intelligence augmentation. But the hard problem is augmentation of who, right? And who gets to control that? And the much gnarlier questions to grapple with are the business models that these technologies are used for. This book from the 80s by James Benninger called The Control Revolution, Technological and Economic Origins of the Information Society, has got a whole chapter in there of one modern control technology, which is called advertising. That's what advertising is. So my second last slide, I beg your pardon, suggestions for a research agenda. All right, first up, I think there's the simple thing of making fair comparisons. I made a bit of a fuss about bureaucracies. I think it's a very reasonable thing to do to compare the way bureaucracies make consequential decisions about people versus how a bureaucracy using AI would make those decisions. You could make it a lot better. You could make it a lot worse, right? There's some interesting trade-offs to work out, right? Many of the most significant bits of science to do with engineering are trade-offs, right? What's the trade-off between utility and fairness? And, to reiterate my point in terms of acronyms, focusing upon intelligence augmentation rather than artificial intelligence. This is the last slide with content, right? So getting on with mechanizing ethics. So to go back to Eric Havelock, I told you I was impressed by him. A true alphabet, the sole basis of future literacy, could only become operative when its components were robbed of any independent meaning, whatever, in order to become convertible into a mechanical mnemonic device. So those who might think that ethical reasoning is something deeply human and we couldn't possibly give to a cold calculating machine, the history of our species suggests that, well, that's the wrong way to think about it. So that's my speculation, my provocation, that it, by mechanizing, we can actually improve ethics. And rather than worrying about computers making decisions, focus upon for whom they're making the decisions. Right? I think that's the root cause. We've already mechanized memory, we've mechanized arithmetic, we've mechanized pattern recognition, and we've mechanized locomotion. Our machines, when used well, could help us to do ethics better. So we could just do that. So that's all I've got to say. Sorry, I'm 5 minutes over my target. Some details of these ideas are in 2 papers that are available in a folder. If you grab a photo of that QR code, I've tested this, you just use your phone, it'll take you to a URL where you can download the PDFs and also my slides. Thank you.